contiguous memory location. So here, when you read this sentence, so array is basically used to store collection of elements. Suppose I want to store 3 elements, I have to declare 3 variables, right? And then I have to use every variable separately. Suppose I want to have 1000, I want to store 1000 numbers. I cannot declare 1000 variables, right? This becomes messy. So instead of that, this is how you declare array. So when you declare array, you have to put this square bracket and then give a variable name. Here I can have any number of elements here, but all the elements are same data type, right? All the elements are integers. Now this will, in the memory, it will be stored in contiguous memory location, meaning 10 will be stored, each are integers, right? Let's assume that the address is 1000 here. The 10 will occupy 4 bytes. So 20 will be stored in 1004 and 30 will be stored in 1008. So this is how it will be stored in contiguous memory location, and you can access the elements using a single variable. Suppose the array elements are accessed using the index. The first element starts with index 0, the second element 1 and third element 2. So if I put this array, right, numbers of 0, you will get the first element 10. If I put 1, you will get 20. 2, you will get 30. So this is how you access the array elements using this index. In square bracket you have to use and you have to access it. Okay, so this is what is array. The advantages: using a single variable you can access multiple values. Now array, what we saw is a single dimensional array. Okay, there are a list of elements, right, single dimensional. Now what if, right, each element in the array, right, so here each element in the array is an integer, correct? So in a 2-dimensional array, right, each element in an array is actually an array, right? Suppose I have an array like this, right, which has 1, 2, 3, 4. Here each element is an integer. Now instead of that, I can have something like this. Each element can be an array. This is the first element, and this is an array, and this is the second element. This is the array, and this is the third element, and this is an array. Okay, so here the data is stored in matrix form, right? Matrix like rows and columns, right? So here, how to access the element? Now, what is the variable here? So for 2-dimensional array, right, inside you have to put 2 square brackets, right? So here the variable name is matrix. Suppose I do matrix of 1, what will refer to? So this element, right, this is the first element, this is 0, this element index is 1, this element index is 2. Now when I put 1, it refers to the first 1-dimensional array. Now if I put in this, I am accessing the second element. Here in this array, this index is 0, this index is 1, this index is 2. If I put 2, it will refer to 6. So this will give me 6. Similarly, matrix of 2 of 0. What will refer to? Matrix of 2. First we will go to the third 1-dimensional array. In this, 0 means what? First element, which is 7. It will give you 7. Right? This is what is 2-dimensional array. Like that we can have 3-dimensional, we can have 4-dimensional, any number of dimensional we can have. Right? 3-dimensional array means what? Array, inside there is an array, and inside that array there is an array. Okay. Comma 5, 6, comma 7, 8. Now, if you see this, right, inside this is the outer array, right? Let's assume this is A. So A of 0 will refer to the first element. So this is the first element. This is the second element. Right? This is 0, this is 1. So it refers to the first element. In this, I am referring the second, in this I am referring the second array, which is this one. In this array, this is the first element, this is the second element. Right? And in this array, this is the first element, this is the second element. Here if I put 0, in this 3, it will refer to 3. So like this, you can have multi-dimensional arrays also. Okay, and so initializing array, you can initialize like this. Okay, internally it will use a new operator to allocate memory for an array. Okay, so basically, right, just remember, when you compile a program, you get a byte code. When you compile a Java program, you get byte code. Okay, and then when you execute the byte code, what happens is, when the JVM executes the byte code, it converts the byte code into machine code. Okay, and then it puts in the RAM. Okay, and in the RAM, this complete machine code, how it will be stored in segments. You will have your Java program will be in text segment, data segment, okay, heap and stack. So these are all the major segments. This is how your program will be stored in RAM. The text segment, right? Text, T-E-X-T. The text segment will contain the instructions. Your data segment will contain all the memory for the variables, global variables and all. The heap segment will have the memory for the variables allocated using new operator. This is dynamic memory allocation. When you declare inside a function, right, you declare a variable int a is equal to 5, correct? So here, this memory will be allocated in stack. Inside a function, you allocate memory, it will be allocated in stack. Inside a function, you allocate memory using new operator, like this, it will be allocated in heap. And when you declare global variables, right, which is above the function, suppose you have a function, above the function you declare any variable, right, that will be stored in the data segment. This is what is called as process address space, and this is how your program will look in the memory. So your program has to come to the memory for CPU, it will fetch the instruction from the text segment and it will execute. So data and all, it will refer to the data in data segment, heap and stack. Now new operator, when you declare an array, you can declare like this. This internally will use a new operator to allocate memory for 5 variables. Otherwise you can declare like this also. Like you can use new, the square bracket, and then you can assign value. This is also valid. Okay. Otherwise, if you don't want to initialize the value, you just declare allocate memory for 5 integers like this. When you allocate default value, if not initialize the elements, the default value will be 0. Here you are initializing with some value, right? Here you are not initializing, so the default value will be 0 here when you do like this. Now what is problem with array is, it is fixed size. Once created, right, it cannot be changed. Suppose I create like this, right? I'm giving as 5. No, I can use only 5 elements. I cannot store more than 5 elements. So that is a problem with array. It's fixed size. So you cannot, there is no insert, delete functions available. Okay, we have to manually shift and add. Okay, so that's a problem with arrays. Okay, if suppose I declare an array of 1000 elements, I am storing only 50 elements in that. Rest of the memory is getting wasted. So to do this, we use dynamic array. So there is something called as array list, which we'll see later. It is part of collections in Java. Collections in Java is nothing but data structures to store collection of values. Okay, that is called dynamic array, which means like dynamically we can increase the size of the array. You can resize the array. That is what the array list, which we'll see later. Okay, so here we already saw contiguous. Contiguous means the data will be stored in contiguous memory location. Each integer is 4 bytes. So first if it is stored in 1000, next element will be stored in 1004, next is 1008, and so on and so forth. So this is how the data is stored in an array. So let me write a program on array. So the file name is array. So I need to have a public public class array, and in the public class array I need to have a main function, which is public static void main. So I have a public static void main. So now I have to declare an array, right? So to declare an array, this is the thing. I give the name as ARR, and then it is giving me, right? Okay, so now I have 5 elements in the array. Now I have to print, I have to loop through all the 5 elements, right? So I can loop through like this. I have a variable which index is 0, and then the I value less than. Okay, so here the I has to go to the array length. So array has a property called length and then I plus plus. Okay, so here I have to print the elements. So I will be printing the array of I. Okay. Okay, so here if you see, right, I am looping through the index from 0 till the length. ARR length will give the length of the array. In this case, it will give 5. So until less than 5. So the loop will run from 0 to 4. This index is 0, this index is 4. And I am printing all the elements. Right? Now it is giving me an error. Let's save it and check. So I compiled the code, I didn't see any error, and after I compiled, I got this bytecode array.class. Okay, this is a bytecode. Now if I execute it, okay, I am getting all the, it is going through the loop and it is printing all the values. So this is one way to loop, where the loop runs from the index, right? I am using the index value. So to access the array element, use the array name, the square bracket and the index value. So instead of I, if I put 4, now it will print all the fourth index alone will be printed. For the fourth index, this is 5. So here 5 alone will be printed. Okay, only 5 alone will be printed. If I use I here, this is a loop variable. And what is the value of I? It runs from 0 to 4. So all the values will be printed. So this is one way to loop. There is another way also to loop. That is called the for each loop. Like for, you can put int any variable val colon the array name. Okay. Now here, there's another way to loop. This is another format loop, another for loop. Here the right side, right, after the colon, you should have an array. It should be an array, and when the loop runs, right, this val will get all values in the array. First the val will get 1, next the val will get 2, next to 3, next to 4, next to 5. So this also will print. Let me comment this off. No, let it run with both the things on. Okay, first compilation, then when I run it, see the first loop printed all the values in the array. The second loop also printed the same thing. This is another syntax to loop. Both the ways we can do. This looks little easy. Like if I don't want the index, I want only the values in the array, means this way also we can loop.